Intel's XeSS technology could be a really big deal even if you don't care at all about the current generation of Intel Arc GPUs. But why? What is it? Well, Intel is confirming that this will be available in major games like Call of Duty Modern Warfare 2 at the game's launch on October 28th. So this is coming fairly soon, but why would you care? What even is it? So if you haven't been following this, it's basically Intel's version of DLSS, where you render the game internally at a lower than native rendering resolution, and then it outputs an image that's been upscaled using some AI algorithms to try to increase the performance while maintaining an image quality that is very similar to the native resolution. However, in Intel's video that they recently launched here, I will say that this is a 1080p quality video, and it's a pretty badly compressed 1080p quality video. So while both sides of the screen here look pretty similar to me, they both look like very YouTube compressed kind of bad images. So this is definitely going to need some testing when it's actually out to see how good is the image quality. But there's at least a chance that this would be superior to something like FSR coming from AMD, because this has some of the advantages of FSR, with also some of the advantages of DLSS. Could this be the happy medium middle ground? Well, so here's really the difference. DLSS is exclusive to NVIDIA GPUs, and not even every NVIDIA GPU, only RTX branded NVIDIA GPUs, because the DLSS technology is accelerated on the Tensor Core hardware. So older GTX cards and AMD GPUs can't use DLSS, whereas AMD has fired back with FSR, which again runs a game at a lower than native rendering resolution and outputs an upscaled image. But the FSR 1.0 version isn't truly an image quality competitor to DLSS because it was a spatial upscaler. It didn't use any previous frame data or anything like that in order to give you a really well reconstructed image. Whereas FSR 2.0 does use temporal data. It doesn't have any AI involved in the upscaling algorithm itself, whereas XeSS does. Now here's the thing. AMD's big advantage was that FSR could run on AMD GPUs as well as NVIDIA GPUs, including GTX NVIDIA GPUs that didn't support DLSS. XeSS should also be able to do this with this compatibility kernel. So Intel is confirming that on their GPUs, there is a specific Intel kernel which is going to be running this technology best. It will run best on Intel hardware. However, they have a compatibility kernel that will work on other vendor GPUs as well as Intel's integrated GPUs. Now, to do this, it's using what's called DP4A. Let me shrink myself down here. Now, this should be supported on a wide variety of GPU hardware, although nothing truly ancient. Most people's fairly modern GPUs would be able to support this. Now, what this does is it allows it to run four operations in parallel, four multiply and compute operations in parallel that would which accelerates how quickly it can do this. However, this could be a big drawback when you compare it to how it will run natively on Intel's hardware, where their XMX cores are going to allow it to run 16 of these operations in parallel. So you'll see that that is a 4 times difference in how fast it should be able to compute the XeSS algorithm. Now, does that mean that it's going to be 4 times faster in terms of frames per second when running on Intel hardware? I don't think so, okay? Now, they've given us some frame rate counters and things like that for how this runs in specific games on Intel hardware, but they have not shown what this looks like using this DP4A fallback support. Also, they haven't said whether or not, all games will support both. In fact, in Intel's rather long video, which I did watch, it did seem to hint to me that the game developer will get to choose whether they're implementing just the Intel version or also implement the compatibility version. So it's certainly possible that some games won't support both. I'm hoping it really does support the compatibility layer at launch from both of them. And there are lots of games being confirmed to support this technology. But again, as I was saying here, they've given us some performance numbers, and we're getting some big performance boosts. And it seems like the worse a game actually runs, when you look at it in terms of actual frame rate, the larger boost you can get from running XeSS. Here's some numbers at 1440p in performance mode, running on an Arc A770 GPU. And then again, converted to a percentage uplift or a multiplier uplift. It's looking like in games like Ghostwire Tokyo, we can actually see over doubling of the frame rate, which is a big deal, whereas some other games are certainly a smaller boost, like 37% uplift in Chivalry 2. And then at the balanced mode, you see less of a performance gain, but still pretty significant, with some games around 26%, but other games like Ghostwire still going up to 75%. By the way, they did say that these games were all running at the completely maxed out graphics settings. So what's going on here? Well, in the actual pipeline of how this process works, what's going on is the way that this gains performance. And here's why I don't think that, even though you're seeing 4 times as many operations happening in parallel here, that the actual frames per second gain would be a 4 times difference is due to how this actually works here. So where you're gaining most of the performance is by taking the actual render of the image, which takes a really long time at high resolutions, and reducing the resolution that is rendering at. And that gains you, this is like your frame time calculation. And cutting down that render resolution gains you a huge amount of time. And then you're replacing temporal anti-aliasing with XeSS. And it's this XeSS operation that basically just needs to take less time to compute than what you gained by cutting off the render resolution, cutting that down, right? So as long as the XeSS process, it's that piece that I guess could take 4 times as long on the DP4A if we just look at it in this simplified manner. Now, it's also possible that they're optimizing this to run differently and more efficiently on the DP4A, and I wonder if that could also impact the actual image quality output that we get. So there's a lot of questions to still be answered here, but it's this XeSS process that's going to either take longer to do, or maybe not run quite as well to get quite as good of an image quality output, or something in between. That's going to be the difference in the compatibility bits. Cutting down the render resolution is still going to gain you a massive amount of performance in many games and situations. So basically, there's still a lot to find out about, exactly which games will support this, which ones will support the compatibility layer, and how good this will actually look. But I'm very excited to see this. And like I said, this could be a really big deal, especially if this can run as fast as FSR 2.0 on non-Intel GPUs, but deliver image quality results that are more in line with DLSS. Like I said, this could be a really big deal, but we still have a lot to find out. I'm excited to see where it goes, though. I hope all of you have an excellent day.